So in this LAB1 video report, I'm going to first make an introduction and discuss the physics principles, and then do a force analysis, and then show my handwritten calculation and the computational model, and answer the two reflective questions. So this is the introduction of this lab. The purpose of this lab is to determine the amount of excess or deficiency of charge on a piece of clear tape. So we all know that all ordinary objects can have an excess or deficiency of negative charges, resulting in a negative net charge or positive net charge when they are charged. So if we want to get an approximation of the amount of excess or deficiency of charge on the clear tape, we all know that a clear tape must have more than the charge of 1 electron in order to be charged, and it also must have less than the charge of a mole of electrons. So, which is that the magnitude of the charge on the clear tape must be between 1.6 times 10 to the negative 19 coulomb to 1 times 10 to the 5th coulomb. However, this range is big, so we need to do the experiment to narrow the range and have an accurate approximation. So the method of this lab is to first determine the sign of charge on the tape by contacting the tape with another charged object with a known sign of charge, and using the rule of like force repel and unlike force attract principle to determine the sign of charge on the clear tape. And then we need to calculate force on the electric force on the clear tape by using the tape's gravitational force, since when object is at equilibrium, all forces are equal. And then in order to calculate the tape's gravitational force, we need to use Newton's second law. The physics principles that are present in this lab can be divided into three main categories. First is the electric force and field category, and then is Newton's second law, and then is the balancing force. So under the electric force and field category, there is like charge repel and unlike charge attract. As mentioned before, we will use this principle to determine the sign of the sign of the charge on the clear tape. And then is the F equals QE to calculate the electric force vector. So we'll use the charge on particle B times the electric field of A, and then from that equation we can then derive the last equation is to calculate the magnitude of the electric force. We'll use 1 over 4 pi lambda 0 times the QB square over D square to calculate the magnitude of the electric force on B from particle A. And then we'll use Newton's second law, which is F equals mg to calculate the gravitational force. So we'll get the mass of the clear tape, and then we'll times it with the gravitational acceleration force, which is 9.8, and then we'll use the balancing force category. So QB equals QA. And then the magnitude of the electric force is equals to the magnitude of the gravitational force. So this is a simple force analysis. So the two black dots represents the two electrons on the tape A and tape B, and then the orange arrow represents the gravitational force, and the blue arrow represents the electric force, and these two forces are equal, so making the tape B floating in equilibrium. So left is my computational model and the result I got from that model, and on the right is my handwritten calculations. So in order to do the calculation, I need to make two assumptions. First is that all tape have the same net charge. Second is that treat each tape as if it is only an electron located at the center of the tape. So the charge on tape B is negative 2.4 times 10 to the negative 9 coulomb, and there is a total of 1.5 times 10 to the 10th electrons. The ratio between electrons and the atom is 1.7 times 10 to the negative 8, and the red dot represents the particle B, and the blue dot represents the particle A, and the blue arrow represents electric force, orange arrow represents gravitational force. So the answer to the first repetitive question is that nothing will change if the electrons and the protons switch charge, because the sign of charge don't matter in this lab. And then it is very important to handle charge tape as little as possible, because when the charge tape is in contact with the hand, there will be charge transfer, so it will make the result less accurate.